Hey guys, welcome to Pepcoding. Today we are going to learn another question, Pepcoder and reversing. Basically, in this question, we also call it by 01 BFS. In this question, we would be given two integers m and n and number of vertices and number of edges. Okay, so cool. So we would be given this and basically let me explain you the question on open board. So basically, suppose we have this one is connected to 2 is it by this connected to 4 connected to 7, or let's say reverse the connection connected to 5 and this connected to 6. So basically this is my source, this is my destination. Okay, if there are 7 vertices, then first vertex would be source, 7 would be destination, and what I need to do here is basically here I need to find the number of directions that I need to reverse to reach till 7. If I travel from 1, then I can go to 2. I can't go to 3 or 6. Then I need to reverse the direction. Okay, here, like this. I need to reverse it. Then 3 to 4 I can go easily, then reverse again. So 2 times I need to reverse. If I go to 6, reverse, then reverse and reverse. Reversing 3 times would get me to the answer. Okay, so what's the big idea here? Let's see. So I hope guys you know Dixon's algorithm because we would be using it here. You need to watch the video for it. Even if you don't, then also we would cover up some part. But I hope if you would have watched it, it would be much easier. So let's suppose that I initially put my original edges weight to 0. And I create another directional edges for everyone. And give them weight as 1. Okay. Now what? Now I make a priority queue. This is my Dixon algorithm. I add simply 1 here, 1 comma 0. It would be removed. It neighbor 2 comma 0 would be added. It would be removed. 3 comma 1 and 6 comma 1 would be added because I am traversing in opposite direction that I have made. Okay. When I traverse this, then see, now what would be popped? It's a priority queue. Any of these could be popped. Let me remove the elements that I have already removed. Suppose 3 comma 1 is popped. Then 4 comma 1 would be added because it's 1 plus 0 weight. So total weight is 1. Now 3 comma 1 is removed. Now suppose 6 comma 1 is removed. Then 5 comma 2 would be added because it has 1 weight and previous weight was also 1. Now what? Now 4 comma 1 would be removed because it has lower weight. And 7 comma 2 would be added. Now 5 comma 2, suppose 5 comma 2 is removed and 7 comma 3 is added. Then this time 7 comma 2 would be removed. And since my destination is reached, it is 7, so I'll print 2. That would be my answer. Okay, so I'll return from here. So this was Dixon's algorithm, but guys, here's a catch. Suppose here would be something x comma 0 or something, anything like that. Okay, so after 2 comma 1, when I was adding 3 comma 1 and 6 comma 1, something x comma 0 would also be there. Then all of its neighbors would be present, and I don't need that. This much complexity is not worth it. So basically its time complexity would be e log n. this is bothering me. I don't want that. I can make it shorter. Let's see the optimization. Let's work on the optimization. If I simply make a queue right here, add 1 comma 0 is added. It is from here, added from here. It is removed, then again add from here 2 comma 0. Remove it from last. Now add 3 comma 1 and 6 comma 1. Okay, so when I remove 3 comma 1, then if my weight is 4 comma 0, in this case, if the weight is 0, then I'll add from first, else I'll add from last. Okay, so 4 comma 1 is there, so I'll add it from here. Now this would be 4 comma 1. Now I'll remove it, add 7 comma 2. Okay, now what? When I am adding 7 comma 2, I have added from first, but the condition was if the weight is 1, added from last. So 7 comma 2 is added from here. Now what? 6 comma 1 is removed. Weight, what's my weight? Let me take it to here. This was 6 comma 1, 7 comma 2. 6 comma 1 is removed. Now 5 comma 2 would be added. So weight is 1. So I'll add it from here. From last. This is removed. Then 7 comma 2 is removed. I get my answer. Okay. This will give me my answer since it's the destination. So guys, this is my answer. I'll return it from here. And this was easily handled. I don't need to traverse extra for this. So let's code this. Let's code the problem. The space complexity is handled here. Okay. So here first I need to make the graph. So let's make it. So array list of integer graph, let's name it graph, is equal to new array list so now for int I equal to 0, I less than n I plus plus. So here graph dot add new array list. So I'll basically add a new array list, and now for int I equal 0, I less than. Now I'll add all the edges. Here, sorry, SG. I'll have to take the input like this. Okay. Here, this is my U. And this would be my V. Now what? Now graph dot get I dot get I get u dot add v, add a pair. We'll make a pair class and v comma 0. This is when we have added the direction that we were supposed to add. Now add the direction that we were adding on our own, that we were not supposed to add, but we added for our own benefit. Now let's add that. Okay, so yeah, now let's make a linked list of integer. Let's say its name is q is equal to new linked list. Okay, let me make the pair class also. Public static pair int vertex int weight public static pair int a comma b vertex equals a weight equals b. Okay, now let's work here only. This must be of pair type. Now q dot add last or add first, nothing matters. I'm adding first element only, so pair 0 comma 0. Now while q dot size is greater than 0, then pair rem equals q dot remove first. Okay, now int vertex equals rem dot vertex, or let's say int v. Okay, I forgot to make vertex boolean. So boolean visited equals new boolean int. So now if vertex is v is equal to n minus 1, in that case I'll simply print, if I have reached the destination, then I'll print my answer. Rem dot wait, and I'll return. Okay, else I need to do the work. So what is my work? First mark visited of v as true, then for int, okay, not int, okay, sorry guys, this was reloading, it was not working, that's why I reloaded it. Yeah, where were we? Yeah, in the for loop. So for pair, not in pair, we neighbor in graph dot get vertex if visited of neighbor is true, return, or not return, sorry, my bad, continue. Else what we need to do, so there are two cases that the weight is 0 or it's 1 if it is already there or if it is not. So let's check that. So if my neighbor dot weight is equal to 0, that is it's legal. I have not created any edge on my own there. In that case, what I need to do, I need to add to the queue dot add first. What would I add? A pair. What will it have? My neighbor and rem dot weight plus 0 or just rem dot weight. I'm writing plus 0 for your better understanding. Else q dot add last pair neighbor comma rem dot weight plus 1. Okay guys, I hope I am clear here. Now outside the while loop, am I outside my while loop? Yeah, here I am outside my while loop. I'll simply print that I haven't got my answer. And what does that mean? I need to print -1, that something invalid is there. Let's run the code. Line 48, public static pair. Okay, forgot to write class public static class pair. And here also I can write public pair or simply pair would also work. Run the code. Line 51, pair int 52, some small error, sorry guys. 55. Are there any extra brackets? Okay, main bracket is missing. Sorry guys, internet issue. Let's see. Yeah, everything's okay now. Line 20, can't find the symbol. Graph dot get you add pair v comma 0. Okay, let's see. Okay, so here forgot to write my keyword new. Okay, now I hope it will run. Still some error. Okay, graph get v new pair u comma 1. In pair cannot be converted into integer type. Array list. Okay, here I have made array list of integer, but it should be pair. Sorry. Yeah. Let's see. Add last pair. I don't know why this is showing error. Q dot. Okay, new pair. Guys, please don't forget to write these keywords. Small errors, nothing to worry about. The symbol. Okay, I have right. Q. Here also it will show the same error. Q. Pair cannot be converted into int. Line number 35. Neighbor dot vertex. 37. Add first. Again same problem. Keyword. Incompatible data type. Pair cannot be converted into int. Q dot add first new pair. Why? I am not converting it. I'm using pair type only. Then why it is showing? Okay, I have put a neighbor here. It should be neighbor dot vertex dot vertex. Okay, my bad guys. Sorry for these stupid errors. The code is rejected. Let me check it. Okay, here bracket is missing. That's why. Yeah. Now I think we are good to go. Let's run this. Finger crossed. Okay, finally. So I hope guys this question was clear. Thanks for watching. Please like, share and subscribe to Pepcoding.